Good morning, everyone. Can you guys hear me okay? Whoa, is it too loud or? No, it's good, okay. I'm not used to a podium, usually walk around and. So I'm here today to talk about Identity X, more specifically protocols like OpenID and OAuth. So if you're not going to remember anything from this talk, there's a couple of things that I'm hoping you will remember. Firstly, these protocols we're going to be talking about today actually have pretty good intentions. And for the most part, they do a pretty good job at addressing some of today's real-world problems with identity management. Also, as you will see, most of the issues that we'll talk about are geared towards the implementation and the design as opposed to the protocol themselves. So first, we're going to start by talking about Identity X.0. Give you a quick overview of what is this Identity X.0 that people talk about, and give you a quick overview of OAuth as a protocol, then talk about some third-party OAuth client applications that you've built, and show you how easily you can do some malicious things with them, and shift gears a little bit about some insecurities and some design flaws with some of today's OAuth implementations. Then jump into OpenID, kind of do the same thing with OpenID. Quick overview, show you a case study of an OpenID compromise, and talk about some design or architectural issues, then wrap it up with a quick summary. So I'll probably need the entire 45 minutes that I have, so I might have to take your questions after the talk, or maybe even off the podium. We'll see how much time we have left. All right, so what is next generation identity X.0, 2.0, which I'm sure you have heard of? It's basically, all it is really a set of protocols and standards that allows you, as a user, to share your identity attributes with different sites. And the goal is to optimize your identity experience, or your online experience within the context of identity management. So what is identity? I think we all have our own notion of what identity is. I think we can all agree that it's a lot of different things. A lot of attributes contribute to our identity. It's who we are. For example, I'm Cash Kiani. That's my official name, and that's part of my identity. It's where we live. I live in Oakland, California, which is having its own identity crisis at the moment, if you've heard of Occupy Oakland, all that stuff that's going on in the States. It's what we do, professionally speaking. For example, as was mentioned, I'm a principal consultant with DeepSec. I do a lot of application security, integration, and I lead a team of pen testers. And I'm also spoken at a few conferences. I blog on socialengineer.org. I blog on AppSec, Santa's Application Security Forum. So all of these contribute to my identity as who I am. Other things we do, or things we like at the personal level. I like watching sports. I like Apple products. I like vacationing in tropical spots. And I like cold beer. Well, not right now, but typically I do. So these are all attributes that I have that contribute to my identity. It's also reputation, things we say about ourselves, things other people say about us, and communication, our email address, the way we get hold of each other, our phone number. These are all attributes that we have that contribute to our identity. When we talk about digital identity, what we really mean is, or what we're talking about is authentication and authorization. Hence the two protocols that we're going to be talking about today. So what is OAuth? OAuth is a permission-based authorization scheme that allows one site to access your protected resources on a different site. And that's really the gist of it. So the OAuth community and the standards committee typically uses the valet key analogy to describe a typical OAuth flow. I guess with the valet key, you can give the valet key to a valet, and he can have limited access to a car. For example, he can open the glove compartment, but not the trunk, or he can drive the car for X number of kilometers before the engine shuts down. Well, I don't know about you guys, but I've never had a valet key. And as I mentioned, I live in Oakland, as you saw, and our valets typically don't need a key to get to your car. But that's a different story. So instead, we'll use banking and also a social network use case. So here we have our main actor, Avon Barksdale. He's not a valet, he's actually a gangster from a TV show Wire. So Avon wants to bank with AIG and Freddie Mac, and he wants a third-party client application like Mint.com to access his AIG and Freddie Macs on a limited scope. So for example, when it's tax time, he wants Mint.com to consolidate all his checking statements. Makes it easier for him. So instead of giving his AIG and Freddie Mac's credentials to Mint, he creates a specific token with very limited scope and assigns that to Mint, so Mint can use it on an ongoing basis to access his protected resources. Same thing is true with social network. So he has Twitter, and he has various third-party Twitter clients that I'm sure some of you have used in the past to access his Twitter account on a limited basis. So for example, to post an RSS feed or to post a picture. Again, he doesn't want to give his Twitter credentials to his third-party clients, so he gives an access token with limited scope and permission. So to provide some context, every OAuth flow has some key actors. So there's a resource owner, that's us, we want to share something, we want to access the content or something like that. And there's a resource consumer, which is the client that wants to access something on your behalf. And there's a resource provider, which is also known as a server, that contains or holds that content on your behalf. And we have tokens all over the place. We have consumer credentials, which are a set of consumer key and secret that are used by the third-party client application to authenticate itself to the server. We have request tokens and access tokens that kind of like act like a user ID and password. And we have refresh tokens. So access tokens are short-lived, and refresh tokens are long-lived that are used to refresh the access tokens. So applying this terminology to the typical flow, we have the user, which is Avon. We have a server, which is Twitter. And then we have a client, which is Twitter feed. A typical OAuth flow is a bit involved, but here we simplified to 4 separate steps. I'm assuming if you really want to get under the hood, you can go and do some research and find out all the transactions that's going on behind the scene. But at a high level, the first thing that you do as a third-party client app, you authenticate yourself to the server. And you do that with consumer credentials. And once that trust has been established, you get a request token. And the request token is really just used for the client to point the user to the proper authorization endpoint on the server where the user actually authenticates, provides consent, and gets redirected back to the consumer or the client. And an access token is given to the consumer that consumer can use on an ongoing basis to access to protect their resources on the server. So there's a lot of redirections going on here. All right, so before we talk about the design issues, let's go over a few sample third-party client applications that we've developed, and can show you how easily you can use these to do some evil things. And if you need the entire source code for all these applications that we're going to show you, just email me, and I can be more than happy to send it to you. So, so we have a native iOS app, and we have a browser-based web applications that we're going to show you. So the first one is the installed third-party iOS applications that we use to steal Google credentials. So the first thing we do, instead of building the app from scratch, we basically go to Google's website, and this app is both available for OAuth 1.0 and 2.0. So we download the OAuth Sample Touch mobile application, which is basically a sample app that connects to a Google Reader account. We go in the main controller class that deals with all the delegation and all the UI web view context, and make some changes. I'm assuming everyone here has 20/20 vision, so you can probably read it. If you can, you probably want to come front. But here the goal is to intercept the request before it's posted to Google's authentication endpoint. So here we are within the context of WebView. We're not really constrained by some of the limitations or some of the constraints that a browser, for example, would apply. So we don't have to worry about things like the same origin policy. So as you can see, we are grabbing the HTTP body, we're assigning it to a string, then creating an array of strings and iterating through it, and based on the prefixes, email, and password, we're just grabbing that and logging it. And that's how easy it is. And while we're doing this, the user is going through a typical OAuth flow on the mobile device, not realizing that in the background, capturing the username and password. So here we're just logging it, but we could as easily just send it to an external server. So the problem is that OAuth provides a false sense of security here around the entire authentication and authorization workflow, because the user is under the impression that everything is legit and everything is official, because everything is happening from a user's point of view within the context of a Google application. So you're a client, a third-party OAuth client, application developer, well, just don't do what we just did. So make sure you manage your authentication and authorization workflow outside your application and within a neutral or third-party application like Safari. If you're a user, don't trust applications that do what we just did. And some of these issues are as a result of lack of proper trust management between the client and the server. And we'll talk about later today when we talk about consumer credentials. So this is a third-party browser-based Facebook application that we use to do some social engineering. Basically, we use this app to gather some sensitive information about a user that we can use to launch another attack. So it's pretty dark. So the first thing we do, we obviously need to make sure that the user can access this application, and we want to persuade the user to go and install it, or not install it, but actually use it. So in this case, instead of targeting the user manually, we use Social Engineering Toolkit, which is part of Metasploit framework, to basically launch a typical phishing attack. We send a link to the user of our app, which is Red Devil Fortune. It's a fortune-telling application, tells people's fortunes. And it's hosted on a proper domain, appsofacebook.com. We launch this towards our target, and the target, once they open up the application and click on the link, they see a typical Facebook permission page, which I'm sure we have all seen this. So Facebook is telling the user a lot of things, but it's also telling the user, hey, this third-party client application wants to access your inbox messages. So you would think that most users are not going to allow some random third-party client application to access inbox messages. But to our surprise, we actually ran a campaign. This was part of a phishing campaign. This many of our users had no problem with this. So that's an issue. So once they click on it, we run our Facebook query language, which is basically SQL. It's called FQL, to read all the inbox messages and basically have access to all their messages. So we could stop there, but we see one message of interest where the user is talking about their banking preference. Again, this is a sample application, so this is not a real banking site. So we use that message when the user is talking about their banking preference to tell their fortune. So this is, again, the social engineering application. So we establishing trust and building a trap so the user can click on it and executing, which will carry out our next attack, which is the Christ-site request forgery attack. Basically, we're executing AJAX postscript to transfer some funds from one account to another. Again, as I mentioned, this is a sample app. We're making some assumptions that the user or the host doesn't have any CSRF protection, and there's a live session going on between the user and the banking sites. But the issue that we're trying to point out here is that, once again, OAuth provides the user with a false sense of security around the entire authentication and authorization workflow, because everything looked legitimate, everything looked as if this was condoned by Facebook. And maybe you and I would realize that, but I think a typical user will have a problem with that. And I really like to know why Facebook would ever allow some random third-party client application to access my inbox messages. That's like giving an application access to your email. But I'm sure there's a business reason for it. All right, now let's talk about some design issues with some typical OAuth implementations. It might seem that I'm picking on Twitter during this section and maybe Yahoo in the next section, but I'm actually not doing that. Based on my experience, a lot of the developers use Twitter, Facebook, Google sample applications as a blueprint when they build their own apps. So these issues are pretty much common across the board. So this is a very basic session management flaw. As you recall, in the use case we showed you earlier, the user uses a third-party client application, Twitter feed, to post an RSS feed. So it uses Twitter as a publisher. So clicks on Twitter, gets redirected to the Twitter's authorization endpoint within the context of Twitter feed, provides his username and password, and posts the RSS feed, goes back to the Twitter feed, and signs out and walks away. Not realizing that in the background, he actually had a Twitter session open. So again, maybe you and I will realize this and go and fire up a browser, open a tab, go to twitter.com, and log out. But a typical user probably wouldn't do that because nothing happened. At no point the user actually went to twitter.com. Everything happened within the context of Twitter feed and within the context of the OAuth flow. So the threat is elevated when a user, for example, is a student who uses computers in various places like the lab or the library or the dormitory. And he could literally leave a Twitter session open on every computer that he touches that uses a third-party Google or third-party Twitter application. So you might think that, well, what's the big deal? My Twitter account gets hacked. We're not talking about sensitive information. We're not talking about a banking site. Well, things can go wrong, actually, if your Twitter account gets hacked. For example, I was giving a talk earlier this year, and while I was giving the talk, later on I found out my Twitter account got hacked. So these messages were posted, and this is probably going to prevent me from ever getting a promotion. So, well, no one cares about me. We saw Fox News. These guys are a pretty big deal in the southern part of the United States. We saw what happened with their account getting hacked, or they say they got hacked. We saw some disturbing messages about President Obama. So these all it could impact the user or the individual at a grand level. Celebrities. Celebrities live and die by the Twitter and the tweets. It must be their ego or something. So we saw happen with Britney Spears' account get hacked. And this could definitely impact someone's self-esteem, appearance. And shortly after this, she went from this to this, just a matter of days. And this is just not good. So it could impact you if your Twitter account is hacked. So the solution is pretty straightforward. In use cases where the user was not already logged in to a server account, by the time he leaves the third-party client application, then his server station needs to be invalidated. So if I'm not already logged into Twitter, when I leave Twitter feed, then when I'm done with Twitter feed, the Twitter account needs to be, or the Twitter station needs to be invalidated. And some implementations actually do a pretty good job at this. For example, when you leave Flickr, it gives you an option to kill your Yahoo session in the background. So this should be the norm, not the exception. How about passwords? I don't know about you guys, but me, when I change my password, I'm hoping that the old password cannot be used in any shape or form, directly or indirectly. And that's fine. With Twitter, if you change your password, you cannot go back to the main Twitter page and type in your old password and get in, right? But you still have all these access tokens that, within the context of OAuth, they really act as a password for the third-party client application to access your content on the server. So these access tokens were granted using your old password, and they're still valid. So the problem with that is that all these access tokens can still access your content. And the reason is because in order to invalidate this, you actually have to go manually to your Twitter account and revoke every access token one by one. Again, something that most users probably won't remember to do when they change the password. Well, the goal here is to make sure that when you change your password, your access tokens or your credentials cannot be used directly or indirectly to gain access to your account. And automation or some sort of automatic access token revocation is probably the right answer. So Facebook actually is doing this right now. So if you change your password in Facebook, it goes and revokes all your access tokens. And that's because it's a side effect of a compromise or breach they had about a year ago where they leaked basically all of our access tokens to a bunch of different third-party client applications. So now if you change your password as a mitigation, they go and revoke your access tokens. So consumer credentials, we briefly talked about this earlier, a pretty highly debatable topic still within the OAuth community. So first thing you do when you build a third-party OAuth client application, you go and get a set of consumer key and secret embedded in your application code. That way, when you make that initial OAuth call, you can identify yourself as a valid, legitimate third-party client application to the server. So you embed that in your code and make the call. So protecting these consumer credentials on the server side is pretty straightforward. You just use your security best practices to protect these on the server. But when it comes to the mobile applications, or given the nature of these applications, the fact that we have a large number of mobile devices, each having to manage their own consumer credential becomes a bit problematic. And the OAuth, the protocol and the standards committee, for obvious reasons, they say that, well, you shouldn't use these consumer credentials for anything other than statistical purposes. That's fine. That's probably a good point. But sometimes you don't have that luxury. For instance, I had a client where they had a use case where the server had to keep track of the third-party client applications in order to charge them for each API call. And you couldn't rely on the user's identity because the user could belong to multiple clients. Also, maybe a server wants to keep track of the clients so you can deprovision these clients or provision new clients on an ongoing basis. So if there's no trust established between the client and the server, then you can't do any of this. So with OAuth 2.0, you are actually have an option to ignore consumer credentials altogether. So there are some new flows that are being introduced that you cannot use consumer credentials. With OAuth 1.0, it was actually mandated. Some implementations allowed you to put anonymous instead of consumer credentials, like Google did that. So if you don't use it, that's fine. You're not running the risk of having them compromised, but you're not meeting my business requirements. But if you do use it, then obviously it could easily get compromised. For example, if you have an open source application, you have to embed these consumer credentials in the code or in the resource bundle or XML file or properties file or something like that. And I think any of us here can go do some Google searches right now and find a bunch of popular third-party OAuth client applications with the consumer credentials in the clear in the code. And this one on top actually not only has the consumer credentials, have the database username and password. So you can do some cool things with that. Closed source clients were a little bit more involved, but this is just one way of capturing the consumer credentials. Again, a little bit more involved, but I think any of us can spend some time and do the same. So in my opinion, the biggest impact is the whole notion of key rotation and kill switch. So if your consumer credentials are compromised, the server is obligated to invalidate the consumer credentials and issue new ones. So the client now has to go and re-register app, get a new set of consumer credentials, embed it in the third-party client applications, and distribute it to all the users. By the time you do that, you probably lost half of your customers. Also, we talked about business requirements where the server had to keep track of the client to charge him for each API call or for deprovisioning. Again, these are the things that make a business impact if the consumer credentials are compromised. Also, as a malicious competition, you could go and compromise somebody else's consumer credentials, anonymously publish them, and perform a DOS attack on the service for at least a couple of weeks. So let's talk about an alternative approach that deviates from a typical OAuth flow. Let's look at the diagram. It's probably more straightforward. So here we have a user, and we have a third-party client application, which is a mobile device that has an associated backend web server. Let's say this is Mint. Mint comes with an installed app on your iOS device and has a backend web server. So when the OAuth flow starts, the user authenticates to Mint.com's backend web server through the installed app using his Mint's username and password, gets a device ID. So this device ID is a new notion, new token that we're introducing here. Then once you get that device ID, you store it safely on your iOS keychain or you just keep it in memory. Then upon that first request to get your access token or to get the original request token, you embed that device ID as a new parameter or append it to an existing parameter when you make the call to the server. Obviously, when the server gets that device ID, it needs to make sure that it's a legitimate device ID, so you make another call to the client's backend server to provide, so that the client can provide the authenticity of that device ID. And then you proceed with the rest of the flow. So we're adding a lot of new steps here, which is a bit expensive, but you only have to do this once. And by the time this is over, the server now can be sure that this request came from a legitimate user and from a legitimate third-party client application, not from a rogue one. All right, so we talked about OAuth. So OAuth, as you saw, had some issues with third-party client applications. Again, in my opinion, it doesn't work well with mobile devices. We talked about some session and password management issues, and we saw that most of these issues are geared towards the implementation, not the protocol. But for most part, actually, OAuth does a pretty good job at defeating the password anti-pattern, because without it, we'll be sharing our credentials with a bunch of different sites. All right, OpenID. So what is OpenID? OpenID is pretty much a decentralized, user-centric single sign-on that helps you manage trust between you and different sites. And the actual OpenID is just the unique URI. So this is my Yahoo OpenID. So every OpenID flow has a user, that's us, and our browser agent, or our user agents, and there's a relying party, which is a site that requires you to provide your OpenID in order to access some protected resources that they're hosting. And there's an identity provider. These are sites like AOL, Yahoo, that amongst other things, they manage your identity, and they hold your identity attributes. And there's the identifier, which is the unique URI that you use to identify yourself. So what problem does this solve? Well, within the context of digital identity, when I think about providing my identity, I think about a bunch of different registration forms. So sometimes you have to go and fill up one of these registration forms to sign up with a site, and all you really need to do is post a comment on a blog. So it might take you 2 minutes or 2 seconds to do that, but you have to spend 5 minutes to post or complete the registration form. So for some users, this could be considered painful, and also you are unverified as a user. And we're talking about a lot of usernames and password, and again, for me, that's not an issue, but maybe for an average user, that maybe for my mom, it is, because she doesn't want to keep track of all her passwords. And I talk about a lot of different usernames, and sometimes you get the usernames that you don't really want because the usernames that you want is not available. And everything happens with the silo. Everything is very site-centric, and sites are not really sharing your identity attributes amongst each other. And same issues can exist with having usernames and password. Basically, it's very directory-centric. All you really are is a single row in a directory, or single directory entry. There's a single authority involved. As a result, it's not portable. So these are some of the issues with username and passwords and typical digital identity implementations. So what does it attempt to mimic? Well, think about our driver's license or any government-issued ID. We go to a single identity provider, trusted identity provider, like some state or federal or national government, to get an ID, right? So when we travel, we don't go every state or every country that we don't go and apply for a new driver's license, right? So this provides consistency so that we can use the same ID to provide our identity to various businesses. So if we want to go to a hotel here, we don't have to register for the hotel ID. We just use our identity that was given to us by a trusted ID that has already established a relationship with these businesses. So that's the concept. So what are the benefits? Other than having a consistent identification or issuance process, there's a consistent verification process. So all you have to do to verify me is to make sure that the picture on my ID matches my face and make sure the ID is authentic. That's all you have to do. So what is the benefit to this? Well, forget this guy. What is the benefit to Lindsay Lohan? I know this is kind of early for this, but what is the one thing that she needs access to at all times? Anyone? Booze. Lots of this, right? So she needs access to booze pretty much every night when she's not in jail. So instead of establishing trust with each liquor store in the LA metro area when she goes for a liquor run every Sunday night, she just uses her ID that was given to her by state of California, and she can use that ID to establish or provide her identity to all the liquor stores. So she doesn't have to apply and register with each liquor store with a new ID. Again, so this is an asymmetric relationship between state of California, Lindsay Lohan, and all the liquor store. So this provides scalability, right? And that's what OAuth attempts to mimic. And every scalable solution usually comes with a side effect. And that's her case. So, but in terms of OAuth and digital identity, same thing happens. You have an identity provider like Yahoo that can use to access different sites. This is a simple OAuth flow. So the first thing that you do as a user, you present your unique URI, unique OpenID to the consumer that holds some sort of content or some service that you want to access. And the consumer directs you to the authorization endpoint on the identity provider. Then you authenticate and then get redirected back to the consumer. Then you can access the content. So there's a lot of HTTP redirects going on, and that's just a very basic flow. There's some trust management. There's some crypto going on here that we're not going to talk about. So let's talk about a case study. So we talked about some of the issues that OAuth attempts to resolve around the complexity that comes with today's password management or identity management in general. But in my opinion, there's something fundamentally wrong with putting all your eggs in one basket. So what are you doing with OpenID? You are putting all your data behind a single door. You're locking that door and giving the key to a single provider. So if you do that, you have to make sure that the identity provider is somebody or something or an entity they can trust with that key. But more importantly, you have to make sure that its identity provider cannot be easily hacked. Because if they do get hacked, especially within the context of OpenID, it could impact a lot of users, and it could be devastating to a large group of users, and also the fact that the user could use the OpenID to access different sites, it could have a major impact. So, for example, with Yahoo, all you have to do to build your or establish your OpenID, you just have to go to the Yahoo's OpenID page and click Get Started, and that automatically turns your Yahoo account or Yahoo ID into an OpenID. So I have a friend who, a couple years ago, was a big OpenID proponent. So he talked about how great the OpenID is, and he can use his Yahoo OpenID account to access all these Web 2.0 sites. So I decided to spend some time one day, see if I can compromise his Yahoo OpenID account. So the goal here was to use some design flaws in Yahoo's password management scheme so I can use to compromise his account. So after doing a lot of research, obviously I found out that the weakest link is Yahoo's password reset scheme. So I went there, and you go there, and you've all seen these. You get challenged with a bunch of questions. The first one was where his father was born. So I knew he was Venezuelan, or his father was born in Venezuela. After doing some research, I got a hit. His father was born in the fourth largest city in Venezuela, which is Valencia. So the second question was, what street did he grow up in? And so I didn't know Jordan when he was a kid, so I had to go and do some research. In the States, we have this site called Zaba Search where you can put someone's name and you can get every address and phone number they ever had. It's a people finder's, it's a free people finder website. So again, after some try and error, I got in, I guessed the right street name, and I was able to reset his username and password. After that, I went and accessed all his relying parties, and not only that, but he had sites like PayPal and Gmail that they had their password recovery mapped to the Yahoo account. So you go to PayPal, reset my password, it links into his Yahoo account. I was able to compromise those accounts as well, change all the passwords, and I thought it was time to let him know. So I told him about what I did and gave him all these new passwords. And Jordan, being a good security professional, he went and did what most of us would probably do. So he went and changed his secret questions and password to something stronger, right? So what is better than compromising your friend's Yahoo OpenID account once in one day? Doing it twice in one day, right? So I went back in, and I saw that he changed his secret question to something stronger. So I put where he went to his honeymoon. This is pretty easy to guess. The only problem is that he's not married, right? Or he wasn't married at the time. And even if we're married, I don't think anybody would ever go on a honeymoon with him. So I knew he probably put some strong passphrase or some arbitrary answer that only he knows about. So I was about to give up until I noticed that little link in the bottom. This is not my question. What do you think would happen when I click on that link? I'm sure you've seen this. You get reverted back to the original question. So again, I already had the answer since I did some research on this. And told him about it. Here's a new password. And again, he was like, I got to try this again. So he went back and he knew that I could get back to his original questions. So he kept the original questions and strengthened his answers to some passphrase instead of Valencia, for example, hoping that these new answers would replace the original questions. But that's not the case with Yahoo, because what Yahoo does basically creates a collection of questions and answers with identical questions and different answers. So all of them would work. Basically, with this, you could always get back and compromise your friend's Yahoo account, or your Yahoo OpenID account in this case. So since then, I actually worked with Yahoo Security, and they made some changes. You still can get to this, but there's some criteria. For example, if you don't use your account for a while, they make an assumption that I don't know, that your account hasn't been hacked, it's you or something like that. So under some circumstances, you can still get to that "this is not my question" link. So Yahoo is doing this because they want to provide some sort of self-service password recovery scheme for compromised account holders' accounts. So basically, they want you to be able to go back to your question if your account has been compromised by an attacker who has changed your questions. So that just shows you they haven't thought this through. So again, the goal here is to, what we're trying to point out here is that if you're using an identity provider for yourself or for your organization, make sure that you're not picking a weak identity provider. Because if they're compromised, it can be compromised at a grand scale. And also we saw how my friend Jordan had left a trail of breadcrumbs with all his accounts. So having his strong authentication scheme, Gmail, linked to his Yahoo account is just not the right thing to do, because I could easily get to his Gmail account through his Yahoo account. So make sure you don't do these kind of things. All right, some insecurities and design issues with OpenID. So I was giving a talk a little while ago at a conference talking about phishing with a different context. And someone yawned and said, well, phishing, that's just an old problem. Well, I know it's an old problem, but so is murder. Doesn't mean that we have to ignore it. If it still applies, then we have to address it. And phishing is still probably the biggest issue and the highest threat with OpenID implementations. So what is the goal of a phisher? Is to access some website using your credentials. So they do that by replicating a site and somehow luring you and convincing you that you need to access this replica so you can enter your username and password, and since they have control over that replica website, you can capture and use it. So there's some complexity in that because they need to make sure that provide some sort of motivation that you would access this website, which you don't really need to access. Well, let's look at a typical OpenID flow. So first you go and visit a legitimate site, right? And that you've never seen before, but it provides some interesting content you want to access. You see a bunch of OpenID logos, and you click on your favorite one, like Yahoo, and log in and get redirected to the authentication endpoint. You provide your password, and then get redirected back to the consumer and leave. Now let's look at the phished OpenID procedure. Well, it's the same thing, exactly the same thing, except the site's no longer legitimate. So OpenID comes with some awesome built-in phishing capabilities for the phisher. So the biggest problem is that OpenID actually teaches the user to follow a link from an untrusted party, or in this case would be an untrusted party from a third-party client. So all the trickery that goes into a phishing in order to create some motivation and convincing you that you need to go access kind of goes out the window. You no longer need to do that as a phisher with OpenID. So for example, if you want to phish someone's Yahoo account, you go and build an interesting website which shows some funny pictures of cats and dogs and put a bunch of OpenID logos on it, and one of them being the Yahoo OpenID logo, and create a replica of the OpenID account, and basically sit back and relax and intercept all the requests that come in. And all you have to do is just make some minor code changes to basically point out to the replica page that you want to go to. Again, this is a sample app that we grabbed and just changed the redirection for the OpenID. So, and then you go into social engineering toolkit and build a fake replica Yahoo login page, and that's how easy it is. So let's look at some solutions that leave a lot to be desired within the context of phishing. So this is my favorite. People always say, well, just educate the users and that will solve phishing problems. Well, that's great, but it's not going to solve all the problems. It's nice to have, in my opinion. Also IPs. Well, IPs don't work well when you're talking about users that are roaming, users that don't have static IPs. It's just not a good solution. And same thing with client-side certs. Again, you have to worry about roaming users, and you have to be able to manage all these clients and their certs, which, again, is not a good solution. I've seen solutions with OpenID providers or IDPs that instruct you to create a bookmark. So when you register with the OpenID provider, you go and create a bookmark, and you may get redirected to the IDP for the first time or even any other time, instead of providing you with an authentication endpoint and asking you to log in, it instructs you to go use that bookmark. Or you can take it one step farther, and actually every time you get redirected to the IDP, it just tells you to go manually enter your authorization endpoint yourself. So these will address some of the phishing issues, but the user experience is pretty flawed. And that undermines the whole notion of OpenID, because OpenID is around flexibility and user experience. So there's a couple better solutions that I think we've seen in the industry today. One is obviously sign-on seals that we see with banking websites, for example. It's a trust that you establish with the IDP, which the consumer, the third-party client, doesn't know anything about. So that works. That definitely reduces the phishing threat. Also, it would be nice to have something like an SSH known host built into your browser. So every time you go to an IDP for the first time, you get warned that, hey, this is the first time you actually go into this IDP. Are you sure you want to continue? Because if it's a legitimate IDP, then you shouldn't be going there for the first time as part of a redirect. You already should be there when you registered. Also, any sort of two-factor authentication. Again, Google does this. These sites all do that, and this is pretty common when people implement OpenID solutions for the enterprise. Also, a quick note about privacy. So if you're considering OpenID again for yourself or for your organization, just have in mind that the IDP becomes a single point of authentication for all your users. So again, as an attacker, if I want to track a user, I no longer have to go and attack the browser. I can just attack the IDP and to have access to all users' tracking. All right, so we talked about weak identity providers. We talked about phishing issues. We touched on privacy. And what are you doing really with OpenID? You're basically outsourcing your password management and part of your security. So if you're doing that, just have that in mind. And just a quick note about passwords. So I think one of the reasons why OpenID hasn't really taken off is because using passwords. And passwords, for most part, it works well when there's only two entities, you and a different entity involved, and there's a shared secret between the two of you. But with OpenID, there's potentially hundreds of entities involved. So that's why it doesn't work well. So again, hopefully you remember that these protocols have pretty good intentions, and for most part, they address some real-world issues with our identity management. And we saw how easily you can make the wrong design decisions and implementations. But I think it's easier to actually make the right design decisions when you're implementing these solutions. And we saw that most of the issues we saw were geared towards the implementation and not the protocol themselves. I think that's all I had. Thank you.